All right, today we're going to be looking at converting things from rational exponents into radical notation, or from radical notation back to rational exponents. A rational is just a fancy word for a fraction, so here we're looking at things that are fraction exponents, so this would be like x to the 1/2, or let's say x to the 1/3. Radical notation is our root notation, so it could be a square root, it could be a cube root, it could be a fourth root, something like that. So if we have a to the 1 over n, that's the same thing as having the nth root of a. So a to the 1 over n is the same thing as the nth root of a. A to the m over n is the same thing as having the nth root of a all to the mth power. So it would be the nth root of a to the mth power. You could also write it as the nth root of a to the m power. So whatever's, oops, I missed my line. So whatever's inside is raised to that mth power. So you can either have it with parentheses and the m on the outside, or that m can take everything on the inside to that power. We call this a rational exponent. Again, when you have that fraction as an exponent, and then we call this radical notation. So some examples of how this occurs, or how we do this. So first of all, if we have x to the 1/3, and we want to rewrite this, so here directions would just be to rewrite. I'll write that over here. So rewrite would be your directions. This is the same thing as the cube root of x all to the first power, but we don't need to write that. If we had b to the 3/4, that's the same thing as the fourth root of b, because that denominator becomes your number inside the radical. We call that an index. It's that number that's kind of squished in there. So the fourth root of b all to the third power, or you could write it as the fourth root of b cubed. You'll see it come up both ways, so you need to make sure that you understand that it means the same thing. The third one we'll look at is if we have a squared times b, all of that to the 5/2 power. Again, that the denominator becomes your index, that number inside in the little squishy part. Since this is a square, a 2 that would go into there, that would be a square root. So you don't actually have to write the 2. It's assumed that it's there if it's not there. So then we have a squared b, all of that to the 5th power. Or once again, we can write it as the square root. But here you would have to have a squared b in parentheses squared, because that whole inside is being squared. I mean to the 5th, not squared, to the 5th. Okay, so you would have the square root of a squared b to the 5th power, or the square root of a squared b to the 5th. Either way is fine. Same thing, we're going to go backwards. So if we come over here, if we have the 5th root of x, we want to rewrite it. So we're going to have x. The big power that it has is just a 1. The index is a 5, so that'll be my denominator. So that would be x to the 1/5. Second one, if we have the square root of ab, that whole quantity cubed. The big power that I have that covers all of my inside is a 3. So my bottom, my base, which is what's inside, is just ab. We're going to take all of ab, since it's all of ab. Its big power is a 3, because ab is to the 3rd power. We divide that by the index. Here there's no index listed, so there's nothing inside here, so we assume that's a 2, because we would say a square root. So this would be ab to the 3/2 powered. Finally, if we look at the square roots of k squared, p to the 3rd, all of that to the 6th. So again, here you can see it rewritten in the other order. So that big power would be my x, the numerator of my exponent. The base of my exponent is what's inside. So this is k squared p cubed. We're going to put that in parentheses because all of this is going to the 6 over And then again, we don't have anything listed, so we assume it's a 2 power. If you notice, 6 over 2 reduces to 3, so we'll write this as k squared p cubed to the 3rd power. And I'm running out of room, but we can go one step further to simplify. Since we know what k squared p cubed, all of that cubed is, we're going to rewrite that as k to the 6th, because we'd multiply our exponents, p to the 9th. So that would be your final answer there. So now let's do a couple more examples. Here, if your directions say to evaluate. So this is where I want you to actually compute the numerical answer to these. So the first one that we would compute would be 8 to the 2/3 power. We're going to say this is the cube root of 8, all of that squared. I'm going to do it on the outside because we know what the cube root of 8 is. We want to keep that inside number as small as we can. The cube root of 8 is what times itself times itself times itself is 8. So 2 times 2 times 2 is 8. So we know the cube root of 8 is 2. And then we will square that, and that's going to give us an answer of 4. So 8 to the 2/3 power is just 4. The second one we're going to look at is 4 to the 3/2 power. Again, we'll rewrite this. We've got a square root now of 4, all of that to the 3rd power. Again, you don't have to write the 2 in there, but if you want to, you can. So the square root of 4 is 2, because 2 times 2 is 4. And then we're going to cube that, which would give me 8. 3, we've got the 4th root of 81 cubed. Here, this is already written in radical notation, so we can just start working it from here. So on this first one, we're looking for what times itself 4 times gives me 81. So if you think about some numbers, and I'm going to give you a list of ones to memorize here in a minute, 3 times 3 times 3 times 3 is equal to 81, because 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81. So the 4th root of 81 is 3, and then we're going to cube that, which 3 times 3 times 3 is 27. So that would be our answer. Last example, before I tell you the powers you just need to memorize, is we have the 5th root of negative 32. So we're looking for what times itself times itself times itself times itself. So what times what times what times what times what equals negative 32. So if you think about this as a negative, when we have the square root of a negative, that would be an even root. We can't have a negative answer, we'd have imaginaries. But here, we've got 5 different terms being multiplied, and we get a negative number. So we know all of these are going to be negative. And then we're looking for what number times itself 5 times is 32. Well, if you think about negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4, times negative 2 would be negative 8, times negative 2 would be positive 16, times negative 2 would be negative 32. So the 5th root of negative 32 is negative 2, because, again, negative 2 to the 5th power is negative 32. So here are the powers you need to know. These are ones that I expect you to know. You will not be able to use a calculator on these problems, so you just need to have these memorized or be able to come up with them. You need to know that 2 to the 3rd is equal to 8. You need to know all of the squared, so anything from 1 squared up to 13 squared. You need to know those, but these are the ones above squared. So 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, and 2 to the 7th is 128. You have to have all of those powers of 2 memorized or be able to come up with them fairly quickly. The other ones you need to know is you need to know that 3 cubed is 27, 3 to the 4th is 81, and 3 to the 5th is 243. Again, all of these we're just multiplying by 3. So 27 times 3 is 81. 81 times 3 is 243. So if you forget one, you can just multiply out on the side of your paper. You need to know that 4 cubed is 64. And 4 to the 4th is 256. And then finally, you need to know that 5 cubed is 125. So these are the ones that you need to have memorized. You are responsible for knowing these and for coming up with them. You will not be able to use a calculator on problems with numbers in this category.